Hey guys, this is a continuation on our genetics discussion. So today we're going to get into probability and Punnett squares, as you can see on the screen. So the question here is, how can we use probability to predict traits? Punnett squares use mathematical probability to help predict the genotype and phenotype combinations in genetic crosses. So hopefully you remember what genotype and phenotype are from your vocab, but we'll go over that. So whenever Mendel performed a cross with pea plants, he carefully categorized and counted the offspring. For example, whenever he crossed two plants that were hybrid for stem height, so remember hybrid means heterozygous, which means it has one of each allele, but in this case it would have a big T and a little t. About 3/4 of the resulting plants were tall and about 1/4 were short. Mendel realized that the principles of probability could be used to explain the results of his genetic crosses. Probability just by itself is the likelihood that a particular event will occur. It doesn't mean it's always going to happen, but just means what's the likelihood of it happening. For example, there are two possible outcomes if you flip a coin. The coin may land either on heads or tails. The chance of probability of either outcome is equal. Therefore, the probability that a single coin flip will land heads up is 1 chance in 2. That's about 50%, or 1/2. If you flip a coin 3 times in a row, what is the probability that will all land heads up? Well, each time you do that, it's an independent event with a 1 chance in 2 that it ends up heads up. So you have to multiply half times half times half, and you end up getting an eighth. So 1/8 of the time you will get 3 heads in a row, roughly. The way in which alleles segregate during gamete formation is just as random as flipping the coin. Therefore, the principles of probability can be used to predict the outcomes of genetic crosses. Mendel's cross produced a mixture of tall and short plants. Each F1 plant had one tall allele and one short allele, big T, little t. Then half of the gametes they produce would carry the short allele. So what that means is, if you look over here are basically the sperm and the eggs, if you will, and half of those are big T's and half of them are little t's. Because the little t allele is recessive, the only way to produce a short plant is to get 2 of them. So 2 gametes, either a sperm and an egg, both with the little t allele have to combine. So this is going from our F1 generation to our F2 generation. You would need to cross this little t with this little t over there to get little t, and then you would get short. Each F2 gamete has a 1 in 2 or 1/2 chance of carrying that t allele. So half times a half equals a fourth. So 1/4 of the offspring is what you would expect to have that little t. And that's basically what he found. So the predicted ratio is 3 dominant to 1 recessive. And this very consistently showed up in what Mendel did. For each of his 7 crosses, about 3/4 of the plants showed the trait controlled by the dominant allele. About 1/4 of the plants showed to be the recessive. Not all organisms with the same characteristics have the same combination of alleles. You just don't know. In the F1 cross, both the big T and the big T, little t allele combinations resulted in tall pea plants. The little t allele combination produced short t. So all 3 of these on the left would be tall. This one over here would be short. Organisms that have 2 identical alleles, so whether it's big T or little t, those are homozygous. Homo means the same. So the homozygous means you have 2 copies of the exact same allele. If you have opposite copies, so hetero means different. So big T, that's heterozygous. So heterozygous and hybrid basically mean the exact same thing. Means you have 1 of each of the alleles. Probabilities predict the average outcome of a large number of events. So the larger the number of offspring, the closer the results will be the predicted value. So going back to that coin flip, the more times you flip a coin, the more likely it is that it will get to 50% of each. If an F2 generation contains just 3 of 4 offspring, it may not match Mendel's ratios exactly, but the more times you do it, the more likely it is that it will turn out that way. Every organism has a genetic makeup as well as a set of observable characteristics. All of the tall pea plants have the same phenotype or physical traits. So, the phenotype is the observable characteristic. So that's just what do you see? In this case, is it tall or is it short? Then you have the genotype, which is the genetic makeup. The genotype is what are the actual alleles. So in the case of the tall versus short, it's the T's. Big T, big T, big T, little t, or little t, little t. Those are the 3 different potential genotypes. Now, you can have different genotypes and still have the same phenotype. So if you're big T, then you are tall. If you are big T, little t, you are also still tall, but you have a different genotype. You are heterozygous. And that's basically what I just said. One of the best ways to predict the outcome of a genetic cross is by drawing a simple diagram known as a Punnett square. Punnett squares allow you to predict the genotype and phenotype combinations in genetic crosses using mathematical probability. Write the genotypes of 2 organisms that will serve as parents in the cross. In this example, we will cross male and female osprey that are heterozygous for large beaks. So we're going to use big B and little b. They each have genotypes of big B and little b. So there are your possibilities. Determine what alleles would be found in all the possible gametes that each parent could produce. So this one right here, the one on the left, has a big B and a little b. So it can either give a big B or a little b. The one on the right can also give a big B or a little b. Well, then we take those possibilities and we put them on one side, on the left side, and then the top. So you draw a table with enough spaces for each pair of gametes, enter the genotypes of the gametes produced by the parents, and then you just label them like this. So I'm going to make a separate screencast of exactly how you do this. And then you just drop the ones on top down into the boxes below it, and then you carry the ones on the left over into the boxes to the right, and then you would end up with big B here, big B, little b in there, also big B, little b, and little b, little b. One difference I would say here is that I would write this big B, little b, just because you tend to keep the dominant alleles first. Okay, so I'm going to stop there, and I'm going to do some work on a whiteboard for you to show you how to do one of these problems.